So it's called MERN Cafe, Chatting with the RAG. So MERN Cafe is actually a book I wrote that's for teaching MERN fundamentals. MERN, as you may already know, it stands for MongoDB, Express, React, and Node.js. So it's a full stack framework. So we'll move on to the next slide. So this is an education site that's designed for teaching MERN fundamentals. That's obviously built with the MERN stack, and it offers basic product listings and order functionality. And I use MongoDB for storing products and orders, and with Passport managing the authentication. So in this talk, we'll be talking about integrating an OpenAI-based chatbot to our site using a retrieval augmented generation RAG. We'll look at the key RAG concepts, including MongoDB vector search. So the application architecture is quite simple with the React at the front end, Node.js in the middle, and MongoDB as the database. So this is the education site. It's not a fancy one. And we'll start from the basic keyword search, how we use it to search data. So for example, if you implement a chatbot with just a keyword search, what happens? So for example, in our e-commerce sites, somebody come and ask, like, do you have a diamond ring? I'm holding the mic, right? Oh, thanks. So if somebody asks, like, do you have a diamond ring? The question is forwarded to Node.js orchestrator, and the keyword search is performed on the MongoDB database, and it will send a response, and we will just frame it a little bit, and it responds like, yeah, this might be the product you're looking for. Look at our diamond ring, and you can click on the diamond ring and see the diamond ring. But what happens if a user asks slightly a different question, which has the same semantic meaning, but like any unique finds for a special gift? Then obviously there is no keyword such as diamond or ring, and in our product inventory we don't have anything that says special or gift. So obviously the database returns no data, and the MongoDB, the Node.js will send a response saying that, sorry, I couldn't find the product you are looking for. So the keyword search is simple and fast, but it cannot identify any variations or semantic meaning of the text. So here comes the vector search. So what vector search can do? There's a lot of images in this slide, but I try to make it simple. So if somebody asks like a question like any unique finds for a special gift, in Node.js from the orchestrator, we perform a vector search on the MongoDB. So this is achieved by using OpenAI model text embedding ADR002. So when Node.js sends this question, any unique finds for a special gift to the OpenAI embed model, it will create a numerical representation which is called vectors. For example, 0.2, 0.5, and 0.7. And then Node.js uses this numerical representation to search the MongoDB collection. In MongoDB collection, we may have thousands of products in a real-time site. So MongoDB will have all the vectors stored for all those 1,000 products. So this is how we does the search. Like we perform a vector search, and MongoDB returns similar documents such as diamond ring or some other products, with the diamond ring being the top primary document. So then there is a calculation called cosine similarity. I'm not going through the mathematical details of that, but it can be a number. Like if it is close to 1 means both vectors are similar. So in this case, for any unique finds for a special gift and diamond ring, we got 0.75 as the similarity. So that means it's quite close. So we can represent it as an angle, like it is almost 41 degrees to each other. So that means vector A and vector B are similar, and it returns the data diamond ring. So you can always filter the data, like either 0.7, 0.8, or 0.9. Depends on the search score you are specifying. Like I have mentioned the greater than 0.7. So that means it returns data which matches more than 0.7. So this is how vector search performs the query. So you may have a question like we have like almost 1,000 products in our database. How we can have the numerical representation for all those data? Like Also, we will be adding more products into our inventory. So how we can have the vector representation for each of these data. So for that, let us look into MongoDB. So this is how the products are listed in MongoDB. For example, diamond ring is over there. And whenever we create a new document, whenever we create a new product or updated product, we have a trigger configured in MongoDB. So that trigger will invoke an OpenAPI call to the OpenAPI embed model, which is text embedding ADA002, and it will return numerical representation of that particular product. So if you have 1,000 products, the trigger will be always triggering whenever you create a document or update a document, and you will always having the embeddings or the vectors created in your product data. So here the diamond, you have a description like that. The diamond ring features a stunning diamond set in a beautiful, etc. All those descriptions are converted into numeric vectors. Also, for example, we have like more than 1,000 or 2,000 products in our inventory. To make our vector is like, for example, we ask the question like any unique finds for a diamond ring. So that vector needs to be compared to all these 1,000 or 2,000 products. So that may not be an optimized, it may not be that efficient. To make it efficient, we create an index on that particular column. That's called a vector index in MongoDB. So using index and trigger, MongoDB manages to have vectors for all those products in our inventory. So how vector search works together. So when a user asks a question like any unique finds for a special gift, that question is forwarded to OpenAI embed model, and it returns the vectors, the numerical representation, and we use that embeddings to look into our MongoDB vector store. And MongoDB returns, yes, we found some similar documents such as a diamond ring or a yellow watch, and it sends that document data to Node.js, and Node.js will frame that response a little bit and send it back, like saying that this might be the product you're looking for. So user didn't mention anything about diamond or ring, but vector search managed to find a cross match saying that this may be the product you're looking for. But user might be looking for something else. User may not be looking for a diamond ring. So that's where like this response, even though it manages to find a product, it's not that engaging or interactive. So what we are saying here is vector search is efficiently retrieving the data based on the semantic meaning of the question, but it fails to generate an interactive and engaging response. So that's where a large language model like an OpenAI GPT-4 comes in. So let us imagine like we forget about keyword search and vector search. We employ an LLM like a GPT-4 Turbo or GPT-4 Mini. And when user asks a question, any unique finds for a special gift, and we send a prompt to the LLM OpenAI saying that you are a helpful assistant in our e-commerce shop, and this is the question user asked for, and what can you reply? And LLM sends a very polished and engaging response saying that, yeah, for unique finds, should you prefer a special gift? I recommend checking out our collection at Milajo. And the response is quite engaging, but it fails to find a product because there's no product information. LLM does not have access to our inventory, even though we have thousands of products in our inventory, but LLM does not have access to that. So that's what LLM lacks. LLM lacks the information about our current product offerings, but it is able to provide a polished response. So what happens if we combine vector search and LLM? So that's where RAG comes in, retrieval augmented generation. So retrieval is where we retrieve the product and then we augment it and send it to the OpenAI, and OpenAI will generate a polished response. So here when user asks any unique finds for a special gift, it sends the embed model and it gets the vectors. Then it will look it up with the MongoDB vector score, and MongoDB returns similar documents. So after getting the response from MongoDB, instead of sending it back to reactive frontend, it sends to GPT-4 Mini for a polished response saying that you are a helpful assistant at Milajo, and these are the documents we got for the user message. Then LLM identifies that intent and make it a bit polished and engaging, saying that, yeah, it seems like you're looking for a unique finds for a special gift. One great option you might consider is our handmade diamond ring. So now it's very engaging as well as also it's suggested a product and user can go click on it and view the product. So here RAG combines vector search and LLM to find the right information to provide a clear and a detailed response. Yeah, I think the time is up, and yeah, that's all. Maybe I'll just go to the last slide. So it's like when we just ask a question like skies have opened up today in Melbourne, it will suggest you an assorted umbrellas by the power of RAG. So yeah, I will just skip this slide. So this is like what we can improve on our implementation. And there are some helpful resources, GitHub repo for this project if you want to check it out, and some useful articles. And thank you. And this is my LinkedIn QR code. Let us stay in touch. And thank you so much for listening.
Hello, yes, we have lots of questions. So I'm going to ask one of them, and then everybody else is going to have to just connect during the break, if that's okay. So the first one I got in was, does your MongoDB trigger directly interact with the language model, or is there some intermediate service?
No, it directly interacts with the embed model, text embedding at 02. It directly interacts with that and create embeddings. There's no middleware. Like we use Node.js, but it's directly configured in MongoDB.
And be directed, we got more time? Couple of suggestions?
Exactly.
Cool, easy. All right, we've got lots of questions. Brilliant. Have you considered alternatives to OpenAI for embeddings?
I haven't considered, but there are. I considered LangChain actually. That's like next step for orchestration, so that we can manage more complex conversations. So there was a slide here. I just skipped that shows how we can continue the conversation using OpenAI, but we can do that better with a more richer and dynamic experience using a framework like LangChain.
Is a call to OpenAI, is a call to OpenAI needed for every query so the vectors can be compared?
Yes, a query is needed, but we can always caching all the stuff we can implement depends on the performance and requirements and specifics.
I feel like this question is very similar. Would this work if the vector stored in the database is calculated with an old version of OpenAI?
Sorry,
What a tricky question.
Yes, it depends on which model you are. If it's an embedding model, like just embedding ADA002, I'm not aware of any other model. But if it's an embedding model which is designed like just embedding ADA002, it will definitely work. It will definitely create the vectors. And you can always try out the alternatives.
Okay, two more. Where is the Node.js logic hosted? Example, it runs on something in AWS. Do you run one service and one database per store/customer?
No, we can host everything. For example, if you are hosting in Azure, we can host both MongoDB and web application in Azure. So everything will be in Azure or AWS, wherever you want to host it.
That's awesome. So last question. In your opinion, what are the limitations of the currently available LLMs?
Yeah, this is what I like. LLM is trained for a specific data, but it does not have access to our specific data. That's why we use techniques like RAG, using vector source.
Awesome. Thank you very much. That's all the questions.
Thank you so much.